In this video, we're going to have a look at how we can solve the cosine of theta equals half. So figure out all of the values of theta over a range of 0 radians to 6 pi radians. And we're trying to do it in the fastest way possible in this example. So notice that in the previous example, the way in which we did this was, firstly, we took the inverse or inverse trig function of this ratio. So remember, this is a ratio. We took the inverse trig function of this ratio, and that gave us the interior. It gave us the interior angle of the triangle or representative triangle. And then after that, we had a look at where this ratio could also exist over a range of 0 radians up to 2 pi radians, as that was the period of the function that we were looking at before, in that case sine. So in this case, we're going to do the same. We're going to take the inverse function. So in this case, inverse cosine of a half, and that inverse is going to output a value of pi on 3 radians. Now recall, this is going to be the first of many solutions. So what we're going to get is more than one solution. Now the question at hand at first now is, how many solutions can we expect at least for the first period of this, or the first cycle of this function? So remember the concept of a periodic function in that it repeats itself. So the question at hand here, or the one we're working on, it wants to do it over a range of 0 and 6 pi. But before we can do that, let's get our first two unique solutions, and we'll say, let's do it over a range of 0 radians to 2 pi radians. And we'll ask ourselves, well, how many solutions do we expect to see over this range here? And going down to our unit circle, I just enlarge that. Remember, with the unit circle, we know that using the mnemonic, all stations to central, what we're going to expect is that for the cosine function, so f of x equals cosine of x, the positive values of cosine, they're going to be in quadrant 1, quadrant 2 is going to be negative, quadrant 3 is going to be negative, but quadrant 4, that's going to be positive. So what we're going to expect is we're going to have, going up, notice we've got a ratio of half. This is positive, so we're going to expect to have our solutions in quadrant 1 and in quadrant 4. And the angles being for that 0 radians, pi on 2 radians, and then 3 pi over 2 radians and 2 pi radians. So we're going to expect our two solutions in these two quadrants here. Now, going back from our previous video, we derived all of the relationship between the interior angle and the exterior angle geometrically by looking at the way in which the function, or the way in which the triangle moved around the unit circle. So notice that for quadrant 1 and quadrant 4, so quadrant 1, the interior angle is the same as the angle that we're fanning our triangle about, but for quadrant 4, the interior angle phi, the interior angle phi is different to the exterior. And to derive the exterior, we simply use the equation theta equals 2 pi minus phi. So to get the second solution to this problem, I can simply say theta equals 2 pi minus pi over 3 radians. And giving them a common denominator, we're going to get 6 pi over 3 minus pi over 3, and that will equal 5 pi over 3. So our second solution to this particular problem is going to be 5 pi over 3. Now remember, these two solutions here, they're only the first two solutions within the period of this function, so cosine theta. And remember, the question's asking us to do it or find all the solutions over a range of 0 radians all the way up to 6 pi radians. So notice that 6 pi radians is twice that, or sorry, not twice that, 3 that of 2 pi. So if I go 6 pi divided by 2 pi, what we're going to see is it's a value of 3. So what I'm going to get or expect is 3 times more solutions than what's here. And the way in which we can do that is we can say, so I'll get rid of this, we can say that we expect 1, 2, 3, and 4. And the way in which we're going to get the solutions is, firstly, we're going to say pi over 3 plus 2 pi, then 5 pi over 3 plus 2 pi, then pi over 3 plus 4 pi, then 5 pi over 3 plus 4 pi. So the way in which I can work this out is simply looking at Desmos. If we extend a domain to 0 radians to 6 pi radians, let's zoom out a little bit more, go 7 pi, perfect. Turn off our original period. So notice that we're going to get all of these values here. So 1, 2, 3, 4, 5, 6. And we've got 1, 2, 3, 4, 5, 6. So calculating all of these values in here. So using our fractional arithmetic, if we calculate all of these or evaluate all of these fractions up here, these are the values we get. So pi over 3, 5 pi over 3, 7 pi over 3, 11 pi over 3, 13 pi over 3, and 17 pi over 3. And to confirm that these values are correct, let's go back to Desmos and we can see, so wrong Desmos, pi over 3, 5 pi over 3, and so on all the way up to 17 pi over 3. So this method here would be the quickest way to solve all of the values of theta. So all of the values for theta for this trigonometric function here over this domain here.